One interesting concept that you learned back in your algebra or pre-calculus course was the idea of systems of equations. You learned two different methods called substitution and elimination. The idea was that you were given two or more equations and you had to solve them together to find the value of each of their variables. Your solution would always be in the form of a coordinate, would then be true for all of the equations. So this point served as an intersection point. So you basically were finding the solution for all the equations that you had listed. So looking at these two problems right here, I have y minus 2x equals negative 1 and then y minus 3x equals 2. I can actually go ahead and solve this, and I'm going to start out by doing the substitution method in green. Substitution method says take one of your equations, so I'll look at the first one, and solve for a variable. So I'm going to go ahead and solve for my y. And then I'm going to utilize the other equation and I'm going to plug in what I see for y as negative 1 plus 2x. So the second equation is y minus 3x equals 2. So in for y, I'm going to put my equation negative 1 plus 2x. And then minus 3x is equal to 2. And I'm going to simplify and solve. And I end up getting x is equal to negative 3. Once I have my x value, I'm then going to go back to my original equation and I'm going to plug that x value in and solve for my y value. And I get negative 7. Therefore, by the substitution method, the intersection point or the final solution for these two equations is the coordinate negative 3, negative 7. So with substitution method, you are literally solving for a variable and substituting it into your other equation. The next idea I want to show you is elimination. Elimination says get your two equations together and you are going to try to get rid of one of your variables. So in order to be able to get rid of the variable, they must have the same coefficient but opposite signs. So I can already see that I have a y and a y, so that's pretty good. They're already similar. In order to get rid of it, I would need a negative sign right here. But if I'm going to multiply a negative to the y, I need to put in a negative to every single value on the inside. And excuse me, I forgot my equal sign here. So if I'm going to multiply a negative, that's going to turn this into a plus, and that's going to turn this into a negative. And then I'm going to add the two equations together. The y's go away, I'm left with just x, and that is negative 3. And I have now found my x value. And then I'm going to pick an equation, so maybe I pick y minus 3x equals 2, and I plug in my x value, and I'm going to solve. And I get negative 7. Notice that this is the same solution that I got when I did the substitution method as well. So why do I need to know this? I'll never use this in the real world. Well, this brings us to an idea of break-even analysis, which is a type of business application. It's a great example when intersection points become important to us. So let's pretend you're starting up a business where you're going to embroider hats. This business is going to require you to buy thread, hats, machines, and several other items. An important question to ask yourself is at what point will I break even? So this means how long is it going to take the total revenue to offset the total cost? Once you break even, then you can start concentrating on profit. So if I invest in a business, I'm going to invest a particular amount. My goal is to earn that amount back so that I break even. It's almost as if I never spent anything. And ideally, I want to go beyond that and then start earning a profit, which means I'm earning more money than I ever put in. When I think about revenue, it's the amount of money received from a product or service. When I think about the cost, it's the amount of money required to produce a product or to provide a service. So looking at an example, a company is going to manufacture a product at a cost of 65 cents per unit and sell the product for $1.45 per unit. The company's initial investment to produce the product was $10,000. How many units must the company sell to break even? So the key to solving a word problem is to take this step by step. The first line says that we're manufacturing 65 cents per unit. So I've gone ahead and wrote 65 cents, and I'm going to represent per unit by X. I'm then told that the initial investment to produce that product was $10,000, so that is my base value. So you see that to that total cost equation, I am adding in my $10,000. However, I'm selling the product for $1.45 per unit. So that's my revenue. That's how much I'm selling it for. So I'm getting $1.45 times X because that's representing the amount per unit I'm selling. And so in order to get the break-even point, I'm going to take those two equations and set them equal to one another and solve for X. That's going to tell me how many units I need to sell in order to break even. So when I take those two equations and set them equal to one another and solve, I end up with 18,182. So that's the number of products that I need to sell in order to break even. Now maybe you're not convinced that this is a real-world problem, that this idea of systems of equations is useful to us. Well, another concept is the intersection points in relationship to supply and demand. Supply equations show that the relationship between price of a product and the quantity supplied, while demand shows the relationship between the price of a product and the quantity demanded. So our intersection point, we call it our equilibrium point in this context, is where the production levels stabilize, where supply and demand are the same. So let's say I have this question. The demand and supply equations for a Blu-ray disc player are the following, where P is the price in dollars and X is the number of units in millions. Find the equilibrium point for this market. So I'm going to take my two equations, set them equal to one another, and I'm going to find the value of X, which is 4. So this represents the number of units in millions that I'm going to sell. But if I want the actual equilibrium point, I'm going to go ahead and plug that into the value P, because P represents the equilibrium price, and when I solve, I get 122. I hope that you found this video helpful. As always, if you have any questions or concerns, please don't hesitate to reach out.